Hello dear students, welcome to my class. Today I will tell you about the velocity, how the velocity changes under Galilean transformation. So for that, again I will draw the two frames. One is my S frame which is at rest, another is S prime frame which is moving. Okay, three axes are parallel to each other. X prime, Y prime, Cartesian coordinate system. So X, Y, Z. Now you will consider any point particle which is situated at a point P and its coordinates, initial coordinates are X, Y, Z and T with respect to S, and X prime, Y prime, Z prime and T prime with respect to S prime. Now say the particle moves in this path and after some time it reaches some point P prime in space, and the point P prime with respect to S frame, the 4D spacetimes are x1, y1, z1, t1, and with respect to S prime frame, x1 prime, y1 prime, z1 prime and t1 prime. Now if I want to find out the velocity of the particle which moves from P to P prime, what I need? I need two things. One is the displacement vector which is P prime, we have to find out P prime with respect to two frames, and the time duration or time interval which is final minus initial time. So at first I will write down the Galilean transformations equation. So the Galilean transformations equations are x prime is equal to x minus vt, while S prime frame is moving with velocity v along x-axis. Y prime is equal to y, Z prime is equal to z, and T prime is equal to t, since time is universal. Now applying these four equations, what we get? We simply get for P point, what we get? We get what are the coordinates of point P? The coordinates are x, y, z, t and x prime, y prime, z prime, t. And for P prime, x1, y1, z1, t1 and x prime, y prime, z prime, t prime. So I will just write down the Galilean transformation. So x prime will be x minus vt, y prime is equal to y, z prime is equal to t and t prime is equal to t. For P prime point, x1 prime is equal to x1 minus vt1, y1 prime is equal to y1, z1 prime is equal to z1 and t1 prime is equal to t. Now from these two sets of equations, what we will find out? We will find out simply x1 prime minus x prime. What it will be? It will be x1 minus x minus v, t1 minus t. And what will be y1 prime minus y prime? That will be y1 minus y, z1 prime minus z prime, it will be z1 minus z, and t1 prime minus t prime, sorry, here it will be t1, it will be t1 minus t. So these are my four sets of equation which I will use later on in my calculation. So now I have to find out the velocity of the particle with respect to S frame. So with respect to S frame, that means the observer sitting at the point origin O of the S frame. If I write down velocity, and so what it will be? It will be simply the displacement vector divided by time interval, that means delta t. So P prime is displacement vector and time interval finally minus LSM. So with respect to the observer sitting at S, what will be the time interval? Simply T1 minus T. And with respect to the observer sitting as O prime, what will be the time? It will be simply T1 prime minus T prime. Just we will use these things. So it will be x1 minus x I cap plus y1 minus y j cap plus z1 minus z k cap divided by delta t. Now the displacement, if the displacement is small, we can simply write down this one as delta x I cap plus delta y j cap plus delta z k cap by delta t. Now in limiting condition, that means limit delta t tends to 0, delta x delta t becomes dx dt. So we can write down the velocity as dx dt I cap plus dy dt j cap plus dz dt k cap when time tends to 0, when delta t tends to 0. So in S frame, our velocity u is simply dx dt I cap plus dy dt j cap plus dz dt k cap. Now I can write down this one as 3 components of u plus uij plus uz k. So I can write down this equation as number 5. Now we will find out the velocity of particle with respect to S prime frame. So similarly, I will define the velocity as simply u prime, since it is S prime frame. It will be displacement by time. Now here also the displacement is x1 prime minus x prime I cap plus y1 prime minus y prime z cap plus z1 prime minus z prime k cap divided by delta t prime. Now I will use my previous equation 1, 2, 3 and 4. If I put just simply these equations, what I get? I get x1 prime minus x prime, it will be x1 minus x minus p t1 minus t I cap plus y1 minus y z cap plus z1 minus z k cap, and delta t prime is nothing but delta t, and also t1 minus t is equal to delta t. So x1 minus x, as I have already told, delta x minus p into delta t I cap plus delta y j cap plus delta z k cap divided by delta t. Now, when delta t tends to 0, in that case, similarly delta x, delta t becomes dx dt. So we get dx dt minus v I cap plus dy dt j cap plus dz dt k cap. Now dx dt is nothing but, dx dt is nothing but ux, dy dt is nothing but uy, and dz dt nothing but uz. So if we just put down it, so ux I cap minus v I cap plus uy j cap plus uz k cap. So it is nothing but vector u minus v into I. So u prime is nothing but u minus vi. So u prime is equal to u minus vi. This is our final equation. So what we can say? We can say that velocity is not invariant under Galilean transformation, and velocity of the particle decreases along the direction of motion of the moving frame with respect to the observer sitting at the moving frame. S prime. So this is our conclusion about velocity under Galilean transformation.